Good morning. My name is Mike Long. I'm Chief of the Asset Management Division for PennDOT, and I'm going to give a presentation on pavement asset management and preservation, specifically when and where these activities are appropriate. A couple definitions and terms to get things started when we talk about asset management. What do we mean? What do we mean by lowest life cycle cost? And how does preservation fit into all of that? According to FHWA, the primary goals of asset management are keeping the infrastructure in as good or better condition than it is now, developing and implementing a logical plan for how you're going to maintain the infrastructure to the condition that it's at now or improve it, and then containing the cost over the life of the facilities. Lowest life cycle cost, key component of asset management. The definition, according to FHWA, is to achieve or sustain a desired state of good repair over the life of the asset at a minimum practical cost. Now, we define ourselves what state of good repair is within some thresholds, and then we also have to work within our budget. It's not a question of saying this is everything you need to do and how much does it cost to do it. It's trying to work out that repair strategy over the life of the asset at the money that you have available. So it's identifying a structured sequence of all those activities: maintenance, preservation, repair, rehabilitation, and eventually a replacement of the assets. Some other simpler terms for what lowest life cycle cost represents: manage the assets over the entire life. It's doing the right treatment to the right asset at the right time. You're trying to maximize life and minimize cost. And there's obviously an emphasis on preservation because that's the cheapest way to add life compared to other strategies. And I have some examples to illustrate that. The numbers that are on here are not going to be standard numbers that apply to every asset, but they are based on real costs, and then you can see the relative difference between the different approaches to maintaining an asset. So whatever condition it is that you want to measure is on the y-axis, and then time is the x-axis. If your approach was to just build it and let it fail, the cost of reconstruction, what we typically use, is $2.6 million a mile. If you look at the life that gives you before it falls below an acceptable threshold, that works out to $118,000 per mile per year. Take the cost, divide by the number of years, and that's how we establish that. Another approach would be let it deteriorate to a certain level, and then perform a rehabilitation. And these are generally major scopes of work, and we're using $1.2 million a mile, and that extended the life by 18 years. So if you work out what the life cycle cost is, that's cheaper than the 118 that we had on the previous slide. That's down to $95,000 per mile per year. So you bought more time by spending more money, and ends up being a cheaper life cycle cost than just not doing anything. Another approach is to perform periodic preservation when the condition deteriorates a little bit, but still is in good or maybe even fair condition. It's relatively cheap, $700,000 a mile, and what I'm showing here is 3 different cycles of preservation. And by doing that, you extended it by 37 years, and now the life cycle cost is all the way down to $80,000 per mile per year. So that's obviously a longer life, a lower life cycle cost than either of the prior 2 slides. Now, to show what happens if you try and squeeze another preservation cycle out of it, you bought another 7 years, but it's actually a higher life cycle cost than the previous one. You can't keep preserving forever, and if you look at the span of time between these cycles, it's getting less each time. Every time you go through whether it's a mill and fill or whatever the preservation is, you're not going to get as much life out of it as you did the prior one. So there comes a point where it's no longer cost benefit to keep doing preservation. But you might not have the money to do the replacement. You might try and squeeze another cycle out of it just to buy you some time. So that's what this is illustrating. And if I had more cycles on there, they would get less and less life out of each one, and the life cycle cost would actually increase from where the low point was. So you might not be able to hit that sweet spot every time, but there is a benefit to not trying to squeeze more preservation cycles out of it than makes it worth it. So some key points to what that shows. Preservation is a proactive, cost-effective means to extend life. And it's not just defined by what you do, but also when you do it. You're trying to maintain or improve condition, but not necessarily repair severe distress. And you can't preserve it forever. You're going to get added life that's decreasing each time you do a cycle. So here's some common types of work that are considered preservation when they're done at the right time. All of these activities, if you look at them, they can be considered maintenance, they could be considered preservation, they could be considered repair, and it all depends on when you're doing it. If you're trying to do it to a good pavement or even a fair pavement, it's preservation because it will maintain that level of condition. So I don't need to read every one of them, but you can see that it's asphalt pavement treatments that are on the left and concrete treatments that are on the right. And again, all of these are considered preservation if they're done at the right time and cost effectively, and they will extend your pavement life as longer at a lower life cycle cost. We established, related to preservation, we established what we call treatment cycles, and they're defined in our publication 242, that's the Pavement Policy Manual. These are used to just get a sense of what will need to be done in about what window of time. It's not anything other than a planning tool. You get a sense of what the need's going to be in the future so that you can do your planning. Obviously, you're not just going to go out and do it because it's the time or the number of years it says so. You have to monitor the condition and see if it's warranted. It may be too far gone for this treatment, or it might not need it yet. So these are just general windows of time that you can use to plan how much work needs done. And we have this divided by the type of roadway that it is. So a high level bituminous roadway, one that is generally going to be maintained by a series of resurfacings or mill and fills over its life. This is what we're saying the treatment cycles are. So you can use this to plan what needs done. You need to do crack sealing every 3 to 5 years. Shoulder cutting and side dosing are added to these every 4 to 6 years. And that's obviously going to depend on the facility, whether there's, curb or what type of shoulder it is obviously impacts whether you need to do these. There's an option to do a microsurfacing or a seal coat every 5 to 10 years. That might just be used to just extend the time till you need to do the resurfacing, which is shown below. This doesn't mean it's a low-level road that needs to be continuously maintained with seal coats, but you could still do a seal coat on a high-level road just to extend the time till you do the eventual resurfacing. That leads us to the next one, which is the low-level roads, and we call these the seal coat network. These are ones that generally lower traffic, lower types of use, that you can maintain these with a series of seal coats over time, as opposed to needing to maintain a resurfacing schedule. Again, crack sealing every 3 to 5 years, shoulder cutting and side dosing, those are the same as on the high level. Now you're going to do a seal coat or maybe a micro, most likely a seal coat for these roads every 4 to 7 years. But eventually you'll still need to replace the structure. So some sort of resurfacing or leveling course every 15 to 20 years. You can't just keep doing seal coats on seal coats and you end up with pie crust roads that don't have any support. So generally what we're saying is you probably would do 2 seal coats before you'd have to do a leveling or resurfacing and then start all over again. We also have a recycling network, which is sort of a subset of the low level. Instead of using a warm mix or even a hot mix resurfacing, we use cold in place recycling. You have to be more careful of other factors or whether a recycling option is the right one for a road. In addition to ADT, you have to take a look at geometry and even in some cases canopy and drainage to make sure that the cold in place recycling will be effective. So it's a subset of the low level roads that you can designate, and it's basically the same cycle, except instead of doing a resurfacing every 15 to 20 years, you do a cold in place recycling every 12 to 15. They won't last as long. They're significantly less expensive, but they don't last as long, so the cycle is shortened. And then finally, concrete roadways. Again, you have the shoulder cutting and side dosing depending on what type of shoulders you have. You need to do some level or some percentage of joint sealing every 5 years. It's not going to be 100%, obviously. It might be 20%, but you need to inspect them and see which ones need to be replaced every 5 years. Then there's a concrete patching need, and those are a combination of probably full depth and partial depth patches starting in year 15 and then probably every 5 years after that. Diamond grinding is done in 15 to 20. Probably at the same time you would do the patching, you would follow that up with grinding to restore your riding surface and in some cases the texture. And then eventually it would need to be overlaid. Now I have asphalt overlays on here. That's what we typically do. There are concrete overlays that can be considered, but we don't have them defined in our standard cycles. So every 20 to 30 years, or after 20 to 30 years, you're probably going to have to overlay the concrete pavement, which makes it composite, and then it follows a bituminous pavement cycle after that. So to summarize all that, we use treatment cycles as a tool to determine long-range needs in planning. It's not a cookbook, it's not a calendar, it's not something you say you have to go do just because the calendar says so. It's not a metric, it's just a way to give you information to know how to plan. Probably what will happen, I know it is in our case, we determine what our needs are and we don't have enough money to cover it, so you can't do everything in that range necessarily, so you need to prioritize which ones need done. And there's a lot of factors that you use to consider. Could be budget, could be the network of the traffic that's used. You want to maintain the higher level roads, probably do a better condition than the lower ones. So, but again, you have to actually evaluate the condition of those when you're ready to do them, or if you are considering doing it, to see if it needs it or see if it's no longer a suitable treatment. Other things that you can use to prioritize, consider risk. Without getting into a big definition of what risk is, you don't want to have the roads that carry more traffic, and if it fails, it disrupts the service level of the whole network. And then you also maybe take a look at which ones are the ones you better do now, or else it's going to fail, and that would no longer be a suitable treatment. If you have more miles of seal coats, more miles that need seal coats than what you can do, which ones are the ones you better do now, or else the seal coat will no longer be effective. And then you would have to do resurfacing, which is even more expensive. So you want to make sure that you don't miss the opportunity to do proper preservation. And that means selecting the worst within a given state or treatment. That's the same thing as saying that you want to do the ones that are the worst but still appropriate until you can get caught up. Eventually, it'd be great if everybody was doing preservation at the early points to keep it at a higher performance level. But the reality is sometimes you have to do them before they fail. And thank you for your time. Again, my name is Mike Long. I'm Chief of the Asset Management Division. My contact information is provided. Thank you.
Hello, my name is Neil Fannin. I'm the Pavement Materials Engineer for PennDOT Construction Materials Division. Today we have a presentation for the Targeted Overlay Pavement Solutions program that FHWA is promoting. My part of the presentation is on highly polymerized asphalts that we're doing the department is doing a pilot on. So what makes something a highly polymerized asphalt mixture? Highly polymerized asphalts have about 7.5% polymer added to the mix. A normal polymerized asphalt has about 3.5% polymer in the liquid asphalt. The PG grade of a highly polymerized asphalt is about in the range of 76E minus 22 in the MSCR system. That is equivalent to the old system, the old PG system, in the range of about an 82 minus 28. The normal polymerized asphalts are 64 minus 22, 64E minus 22, or under the old system is a 76 minus 22 PG grade, if you're used to that. The big thing about polymerized asphalts is their elastic recovery is a minimum of 90%. This is a little different than the than the old PG, or actually the MSCR PG requirement, where it's dependent on the JNR, and it could be as low as 40% as far as the elastic recovery goes. Highly polymerized asphalts have potential benefit of less rutting, less cracking, less maintenance, and therefore longer life. And I have maybe there because we're not completely sure about these things, because we haven't used them enough, and we don't have a history of data for that yet. The Virginia Department of Transportation did a research project recently on highly polymerized asphalts, and they found that this mixture, the highly polymerized asphalts, do not delay reflective cracking significantly. There was a bit of a hope that that this mix would do that, but pretty much nothing you do really affects working cracks. They're going to come through no matter what. So you still need to fix them. You can't just pave them over, even with this mixture. The Virginia study was a 5-year study, and projecting from the data they got after 5 years, they said that it indicated that there was a 34% increase in pavement life. Now this is projecting out to approximately 20 years. So the projections that they use may converge, they may not, but it's that is a projected outcome. And then the benefit cost ratio kind of is the big thing here for this mixture, because the additional cost for high performance asphalt is about $15 a ton, which equates to about $1.25 a square yard. It's a 10 to 15% increase in cost. So the big issue with this is that do we get the increase in service life that kind of justifies that kind of higher cost. So the question with this highly polymerized asphalt mixture is it worth the added cost? The data really isn't conclusive yet on that, but this is a high premium mix. It is going to be probably one of the best mixes that we have out there, but again, is it worth the cost? Until the data comes back, I think that it's probably best to consider it, at least on projects where you're in a get in, get out, stay out mode, and you want to throw everything you can at it to ensure that you get the longest lasting mix that you possibly can. As part of the TOPS program, the FHWA has offered Accelerated Innovation Development Demonstration Program grants to encourage states to adopt a lot of the technologies that they're promoting under the TOPS program. The highly polymerized asphalt was one of them that PennDOT wanted to participate in, and we applied for a grant for 5 different projects in 5 different districts. We applied for $700,000 total, and we're waiting for that to be approved or disapproved. The approval or disapproval will come in March of 2022. Lydia Petticourt was responsible for applying for this, and all these projects had SMA wearing course projects where we're simply replacing the normal polymer modified asphalt with highly polymerized asphalt in the SMA wearing course. So if you have any questions regarding highly polymerized asphalt, or your district wants to explore the use of these materials, please let me know. My information is there on the screen. Thank you.
Good morning. My name is Lydia Petticord, Chief of the Pavement Design and Analysis Unit at PennDOT Central Office. I'm here today to briefly discuss an FHWA Everyday Counts, or EDC6 initiative, Targeted Overlay Pavement Solutions, or TOPS for short. In particular, I will touch on bonded concrete on composite pavement. Neil Fannin will follow with a presentation on highly polymer modified asphalt. Approximately half of all infrastructure dollars are invested in pavements, and more than half of that investment is in overlays. By enhancing overlay performance, state and local highway agencies can maximize this investment and help ensure safer, longer-lasting roadways for the traveling public. Let's talk about when concrete overlays are particularly useful. Concrete overlays can be used in areas with high rutting potential, where much more frequent maintenance or more frequent overlays are required. With a concrete overlay, you can get in, get out, and stay out for much longer periods of time. Concrete overlays are used on ramps and at intersections. Concrete overlays can be placed as thin as 2.5 to 4 inches thick. How can we ensure that such thin overlays will have a satisfactory performance period? We can add fibers to the mix. A very useful document on this topic was produced by the Concrete Pavement Roadmap, a Moving Advancements into Practice, or MAP, brief in March of 2019. Let's look at the benefits of fiber reinforcement. When macrofibers are added to the mix, we get a smaller crack width, a reduced crack deterioration rate. We can also get either a thinner slab for the same fatigue performance or a longer fatigue performance. Here are some examples of synthetic and steel macrofibers: crimped, embossed or bitapered synthetic, twisted synthetic, straight fibrillated synthetic, and hooked end or crimped steel. Let's take a quick look at the finished surface of a fiber-reinforced concrete pavement. Here you can see the fibers in the surface of the mix. Last year, the American Concrete Pavement Association, Pennsylvania chapter, conducted several virtual regional meetings across the state to raise awareness of advancements in concrete pavement and available applications, and to discuss issues and concerns. This afforded an opportunity to discuss the performance of a concrete overlay on composite pavement. This particular project was an ultra-thin bonded overlay, also known as white topping. It was 4 inches of concrete on 3.5 inches of an existing asphalt surface after a 1/2 inch milling on 10 inches of an existing concrete pavement. The slabs were 5 foot by 5 foot on ramps with a 15-foot wide lane, placed in 2015. This photo was taken 2 years after construction. Some non-working cracking was observed, that is, fine cracking that does not appear to be moving. Fibers had been included to address plastic shrinkage cracking. However, when reviewing the concrete mix design, it was discovered that a very high cement content was used to achieve the accelerated strengths required by the specification. The specification required a minimum of 650 pounds per cubic yard of cement, but did not specify a maximum. 900 pounds per cubic yard were used in the mix design to achieve the required minimum 3,000 psi in 24 hours, and in fact achieved just over 4,000 psi in 24 hours. Contrast that with accelerated patching, which was limited to a maximum of 800 pounds per cubic yard to achieve 1,500 psi in 7 hours. Section 523 is in need of some revisions to help control this type of cracking. Section 541 is to replace Section 523 and has been drafted and is planned to go out on clearance transmittal review in the near future. Cement factor is proposed to be reduced from a minimum of 650 pounds per cubic yard with no maximum to a cement factor of 517 to 611 pounds per cubic yard to match the current Section 501 mix. Accelerated strength Portland cement concrete would no longer be required and instead require a Class AA paving cement concrete. Lastly, polypropylene microfibers for shrinkage cracking would be replaced with synthetic or steel macrofibers for providing additional structural capacity, reducing crack widths, maintaining joint or crack load transfer efficiency, and extending the pavement serviceability through reduced crack deterioration. The department continues to encourage the use of concrete overlays through trainings and webinars offered through the FHWA EDC6 TOPS initiative. I have included a link on this slide to the FHWA website on TOPS for additional information. Thank you for your time and attention.
Good morning, everyone. I'm Jim Casilia with the Pennsylvania Aggregates and Concrete Association, here to give you a brief update on our initiative to reduce concrete scaling across Pennsylvania. This was an initiative developed by the Construction and Materials TAG. It's a timely opportunity to give you this update because this innovation is moving from implementation and development into the specifications very soon. There are two parts to this initiative. First one is certification of finishers. This is going to be done through one of two existing nationally recognized programs, either the NRMCA Exterior Concrete Finisher Certification, which is the preferred program for this class, and the ACI Concrete Finisher Certification. Now, these requirements go into effect for finishers on all projects led after April of 2022. Second part of this initiative is a training module prepared for winter schools for all construction inspection folks. All right, it's a 45-minute presentation, and they get a little bit of the light version of stuff that's covered with the finishers, with emphasis on good practices, identifying good practices, proper workmanship, and proper care of the concrete curing after it's placed. So how is this initiative progressing? I'm very pleased to report since we began this initiative implementation. Right now there's over 450 finishers certified across Pennsylvania, and even more than what you see on your screen because we recorded this presentation in early October, and now that's has some classes been done since that time. So we've got a good number of finishers already certified. For the second part, we were able to get to almost all of the districts with their winter schools already. The only two districts yet is District 12 and 11, and we're scheduled for District 12 winter school this coming winter. But the only one that leaves us is District 11. So on behalf of the Construction and Materials TAG, we're not feeling a lot of love coming out of District 11, guys. So, you know, hint, 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 if there's room on your agenda this year, please give us an invite. We'll be glad to make this presentation, and then we can say that we've hit all the winter schools across Pennsylvania. So where is the specification? What is the specification going to say? It's going to be introduced, it is introduced in the part of Pub 408 in Section 704. And what concrete does this cover? You can see Neil Fannin took the time to go through the 408 and pull out all the sections of concrete work that are in there that needs to be covered. And as you can see, it's fairly all-encompassing. So the safe bet it is pretty much for any finished concrete going out there on any of our PennDOT projects, this requirement is in effect. So how many finishers need to be certified according to this? It is a minimum of 60% of the finishers, and we had a lot of discussion about this number at our Construction and Materials TAG. Why 60%? Well, it's going to require that most of the finishers be certified. It should address any kind of staffing issues, especially if you have newer people coming in to the industry, give some time to get certified. But the key is that we'll have the majority of our finishers out there certified. So If you have a crew of 5 folks finishing your concrete, 3 of them need to be certified. So let's talk about the finishers class a little bit, and in particular why the NRMCA program is the preferred program for this course. It has a 2-part program. There's a classroom part and there's also a performance part that goes along with it. Now, the emphasis of this program, especially during the classroom part, this program's not a do this, don't do that kind of thing. Sure, we go through some of those things, but we really try to delve into what's going on and why. So we can arm the finishers with a little better information so they can deal with all the stuff they have to deal with out in the job site, make better decisions, and maybe just have a little bit of better skill if they have a better understanding of what's going on and why we do that, not just, hey, do this, don't do that kind of a structure of the class. It's an educational opportunity. It's not a difficult test. That's not the focus of this. What we found out, we have never taken the time, we're all so busy working, to just, hey, let's spend a day and have these kind of discussions that we need to have as to what we need to do and why we need to do it. And the classes have been extremely well received. So after the morning portion and the written test, we go outside and we place some concrete. There is a performance checklist that the folks need to go through. Now, it's not a tough thing, but again, it's a further educational opportunity. All right, so we'll stand around and we'll observe the concrete and we'll have discussions on what we need to do at this time and what we shouldn't do at this time, equally important, and why and what's going on. And the other reason that this is the preferred course is after folks go through this, they get a lifetime certification. Its focus is purely on providing the skills, the discussion, what's going on, where we run into problems on exterior concrete. The ICI Flatwork course is a very good course, but they cover a lot of stuff on building concrete because many of our commercial building projects is required as part of the specifications that they have that certification. So they care a lot about building code concrete. With the NRMCA class, we can focus on just finishing concrete, durable surface, so we get the surface life out of it and the appearance that we want and that we're paying for. What we didn't realize when we started this initiative of its possible advantages for municipalities. There's a lot of developments done out there where the curbs, sidewalks get put in, the roadways left in binder course, either residential or commercial development, doesn't matter, it gets built out, then development gets finished, then it's time to finish with wearing surface on the roadway and turn the roadway, curbs, and sidewalks over to the municipalities. Well, sometimes when this happens, the municipalities are forced to deal with relatively new concrete that doesn't look new. It looks ancient because it wasn't installed properly, not the right mix, not the right workmanship for whatever the reasons. And this can be a very hot and heavy point of contention, an argument that we can minimize, not avoid altogether, but we certainly can minimize its efforts with this training program. And one township has taken this to heart. Ferguson Township in Center County. Ron Siebert, their municipal engineer, is a member of the STIC, so he was listening into the development of this initiative since 2019, and Ron approached us and says, hey, I'd like to see about bringing this to my township. And so in February of last year, we did a training program for their municipal inspection personnel and everyone within the township. And Ron invited folks from all the surrounding municipalities to come, and we gave them a version of the presentation that we do for all the PennDOT inspectors at winter school. And then in this year, May of this year, we're able to conduct 2 finisher classes in Ferguson Township. So the majority of the contractors working in that township are certified according to this program. So we feel that that's going to up the game for that township. And that's available to your municipality too. We can come in, give a similar program that we're doing for all the construction inspection personnel, but we can go a little bit deeper. We can help you with your specifications. Let's face it, there's a lot of rules in publication 408, and if you give that whole document to someone out there doing sidewalks. It's, geez, where do I find out the stuff in here that's important to me? So we can make sure that your specifications have the important stuff in Pub 408 front and center, so everybody knows what they are. We can make sure they're consistent with the requirements of 408, that they have requiring the proper material, the proper workmanship, and most important, the proper care and curing of the concrete afterwards. Now, we'll be glad to do this for your municipality. We're going to be a little bit busy between now and April as the specifications going into effect, but contact us, let us know, and then we can work towards you to bring some of the benefits that Ferguson Township is seeing to your municipality. Here's my contact information. It's my understanding that the contact information for all the presenters today is going to be made available to everybody, but there's my contact information you have on the screen. So contact me and we can give you a little further information on what we presented here today on our initiative. And I think now it's time to switch over from the recorded portion of our presentation to some live Q&A. Thank you.
Hello, this morning we're going to talk about geotextile paving fabrics, and my name is Michael Fleming. I'm the Public Works Director from Dover Township in York County. I'm going to talk about some of the uses that we've had. All of them so far have been very successful, and hopefully I can extend some of those project ideas onto you here today, some of those innovations that we've done here. So when it comes to extending pavement life, York County and Dover Township for many years have utilized different ideas, and the photo that you see here was from back in June of 1995 when Dover Township worked with LTAP and local contractor Stewart and Tate to create a training film on RALUMAC, a form of microsurfacing. Microsurfacing is still an approved PennDOT product that can be used today to extend your pavement life. Dover Township and PennDOT's New Products Committee recently completed a pilot project on the use of paving fabrics under a double seal coat. That project was a success, and the process, titled Geofabric Reinforced Double Layer Seal Coat, and that is now an approved process and can be found in PennDOT Publication 447. You'll see, I'll use my little laser pointer here, in the first photo here on the left, the PG material is sprayed onto the road, immediately followed by the contractor spreading the engineering fabric, the paving fabric, down on top of that. The photo in the center here shows the fabric on the road and the contractor applying the first application of emulsion to the roadway. On the photo on the right hand side here, we see the contractor applying the chips. This Geofabric Reinforced Double Layer Seal Coat, like I say, is an approved product now by PennDOT. You can use liquid fuels funds to pay for it, and it's another way to extend your pavement life. We have had success with previous projects using 2-inch overlay on top of the paving fabric, as seen in this photo here. That's a close-up of the longitudinal joint. But on Amick Mill Road, we did over 3,000 feet, and on Rollers Church Road a few years back, we did over 10,000 feet of a 2-inch overlay on top of that fabric. So when we talk about geotextile paving fabrics, obviously there's many advantages to it, to using the fabric, such as they can be an equivalent to adding asphalt thickness to achieve the same performance as adding 1 to 3 inches of paving. The fabrics act as a moisture barrier by preventing penetration of surface water into the subgrade, even if the cracks reflect through to the surface. The fabric set as a stress-relieving interface that retards reflective cracking. Fabrics can also be an adhesive bonding material by providing uniform bonding between the old and new asphalt layers. Fabrics come in varying weights or thicknesses for varying degrees of maintenance needs. Paving fabrics are easy to install on both milled surfaces and on roads with curves. It's probably one of the easiest interlayers to install. Fabrics can be milled and recycled with conventional milling machines, and fabrics are chemical resistant to road salt and other chemical de-icing agents. So the challenge that we faced with our roads here in the area are due to a clay-based subsoil, thin, old, cracked pavements. Some of the roads that we had this year that we dealt with were ballasted with screenings. You'll see in some of the photographs there was a utility trench down the side of the road, and we had different types of curb. On one road we had slant curb, on the other road we had rolled curb and gutters. My funding source for this project was liquid fuels, and we had to be sure that by using liquid fuels funds we were using a PennDOT approved process, and that it was. It's found in Pub 408 section 466, and that section covers asphalt paving fabric. We also were fortunate to be able to use water funds to cover a portion of the work because of the new utility lines that we put in last year. And you'll see in a photograph the existing alligator or chicken wire cracks are shown. This was on Bel Air Drive. Although the road was severely cracked, it has more than 8 inches of ballast with screenings as a base. We had no areas of mud pumping up through, and that allowed us to be able to use the fabric and not have to do a lot of base repair. And keep in mind, these two roads that we did were over 25 years old. So this is the second road we did. This was Raycom Road. It's in an industrial zoned area of the township. The road's nearly 30 years old with lots of cracks. And you'll see on the right-hand side there, there's a water trench that came down through here, and then a few services going to the industrial properties. So that was that work was done last year. We shared the cost to pave these roads with our water department, and we're working on a project coming up here in the near future where we'll have sewer, water, and liquid fuels funds to pay for a development that we're going to replace utilities prior to repaving the roads. You'll notice Raycom Road was over 1,200 feet long, 33 foot wide, and the ADT was less than 1,000 vehicles per day. I did give you the location, the coordinates for both roads on the slide here, should you want to visit the site. And this is Bel Air Drive. This is a residential area. Again, due to rock and several previous water main breaks, we decided to replace the water mains and all the services before repairing the road. Again, the costs were shared between the water department and our liquid fuels funds. This road is all but 1,900 feet long, and the ADT was less than 1,000 vehicles per day. And again, we give you the coordinates in case you'd want to visit the site. So the project, we bid it ourselves utilizing the liquid fuels forms, the MS 944 forms. We had 3 bidders. The bid tab is shown for you there, and awarded the project to a local contractor, Kinsley Construction. Kinsley had subcontracted the paving fabric work to American Paving Fabrics, and as indicated there, we used the 10K Murphy PGM-G4 fabric. The cost installed and supplied was $7.60 per square yard. Our contract was broken down into 4 sections: milling, scratch and leveling course, the paving fabric placement, and then the overlay. And as you see, we did have in the photo here, there's special provisions that talk about how the milling's to be done, how the scratch and leveling was to be completed, what material they were to use, what was the minimum cross slope we wanted. The fabric mentioned which fabric we wanted or a PennDOT approved equal, and how it was to be placed within 2 inches of the face of the curb. The overlay placement was a super pave mixture wearing course PG 64S-22. So we'll talk a little bit about each of the 4 of those parts of the process. In this section here, the contractor was required to mill along the curb line with a 6-foot wide milling head. They milled 1 3/4 inches deep along the curb line and 0 inches deep near the travel lane. The millings were hauled to the township building for use on another future public works project. The contractor then was required to sweep the road after the milling operation. This scratch and leveling course, this portion of the project, the contractor was required to place 9.5 millimeter super paved material and to provide a minimum 2% cross slope before placing the fabric. Surface preparation involved making sure that the road is dry and clean of dirt and oil. Cracks that were greater than 1/4 inch are to be sealed as per PennDOT spec. And another thing to keep in mind, you need to allow any crack filling material to cure before placement of the geotextile paving fabric. In addition, any potholes and other pavement distresses must be repaired as specified in section 450 of the PennDOT 408. Keep in mind that the geotextile paving fabric must be placed on a drainable surface with no depressions, which may hold water in the overlying asphalt concrete. Thus, the reason for placing a scratch and leveling course first. So the portion of the project that involved the fabric is covered in PennDOT Pub 408, section 466. That's the construction portion. The approval of the specific product is in PennDOT Publication 35, Bulletin 15, section 466. In this process, it's a fiberglass reinforced paving grid, which has conditional approval as long as it's placed as per the manufacturer's specifications. The contractor was required to furnish and install the MIRFI MPM-G4 material or equal, which is a reinforced paving grid. The material was placed within 2 feet of the face of the curb. The contractor applied the PG64 asphalt material using a calibrated distributor truck spray bar. The application rate must saturate the geotextile paving fabric to ensure bonding of the geotextile fabric to the existing pavement surface. We applied asphalt material at a rate of 0.25 gallons per square yard to completely cover the roadway with performance-grade asphalt binders. You need to use caution when placing your super paved material so that the temperatures do not exceed 350 degrees because you don't want to damage the geotextile paving fabric when you're placing the bituminous product. You'll notice in the following video that the contractor applied the asphalt material only as far in advance of the geotextile paving fabric installation as is appropriate to ensure a tacky surface at the time of geotextile paving fabric placement. In the video here, you see the distributor truck spreading the PG64 material on the roadway, immediately followed by the tractor that has the roll of fabric on there and they will throw some sand down to prevent the wheels from the tractor sticking to the fabric. And then they proceed down the roads, spreading the paving fabric out. Now in this photo here, you see the tractor proceeding down the road, and as he spreads the fabric out on top of that PG64 material. One thing you need to keep in mind that if you do have to drive on that, you want to make sure to keep the excess traffic off. But you can drive on top of that paving fabric once the PG material sets. So the last part of our project involved putting the overlay down. That was 9.5 millimeter super pave. The contractor was required to furnish and place that. We wanted the 0 to 0.3 million easels material, and we wanted 2-inch compacted thickness. Our skid resistant level was L due to the low traffic volume. If needed, you want to blot the excess tack coat that bleeds through the paving fabric by broadcasting sand on the paving fabric as the trucks pull in and out of the job. As with any paving fabric, the minimum compacted thickness of the first lift of overlay asphalt must be greater than 1.5 inches. And although we were dealing with an experienced contractor as a general and a subcontractor, we did encourage some problems as shown on the next slide. You'll see here that the professional truck driver dumped a large portion of his load in the hopper and in front of the paver. Fortunately for us, the experienced skid steer operator was very cautious by not damaging the paving grid as indicated in the video in the next slide. You'll notice how the skid steer operator / paving superintendent made several back and forth movements instead of just spinning on the reinforced paving fabric. This is another video here of where the operator was protected the paving grid by using the back side of the smooth bucket and only the rear wheels of the skid steer to turn 180 degrees on a reinforced fabric. Obviously, this paving superintendent has dealt with issues like this in the past. And you'll see where he lifts the weight off the front tires, uses the bucket, and he's able to turn himself without damaging any of that paving grid that's on that road. This is a view of the completed wearing course over top of the fabric. Contractor was doing the compaction. We had several sanitary sewer manholes on this project. In the photo on the left, you'll see how the contractor cut the reinforcing paving fabric around the manhole cover prior to the overlay. After the paving contractor was complete, the township went in the following week and cut the new road to raise and install new watertight manhole covers. We utilized a Mr. Manhole cutter that attaches to our skid steer to do this operation. And you'll see on the photo on the right hand side here how that Mr. Manhole cuts a perfect round circle, and then we're able to do the repair. Establish finish grade and raise that manhole frame and cover up to grade. The last part of the project involves the contractor where he's required to seal all finished joints with rubberized joint sealing material upon completion of the paving. Not only does he seal along the curb, but he'd also seal the center longitudinal joint down the road. So feel free to contact me if you have any questions or if you want to visit the site. My name's Michael Fleming, and I'm the Public Works Director at Dover Township. You can reach me at the email address there or just by calling the Township office. Okay, thank you.